here. Some ones I didn't do in those videos would be some more Bayes' theorem questions. So I would watch, if you're wanting to kind of wanting more practice problems, something that would be really good to pay attention to. Also, I have the exam written. So some of those examples I used in the additional video from last weekend that had more Bayes' theorem problems in it. Some of those examples would be really good to see worked through. Wink, wink. All right. So if you're kind of wanting to kind of more Bayes' theorem problems to go over, I would suggest looking at the problem in that video and trying to kind of work it out yourself. Okay. So we'll do one here though that looks very similar to what you could be asked. So we've got steroid use in baseball, blah, blah, blah. So a manufacturer claims the probability a drug test shows positive given that an athlete is using steroids is 0.95. So let's just start writing out what we're given. So instead of using the board here, I'm going to type it out just so we can have, oops, why won't it let me edit this document? Protected view. Okay, there we go. So the information I was given here is the probability that given, right, and I'll use that language on the exam too, given an athlete is using steroids, so we'll say using, right, the probability that given that they're using steroids, the probability that the test shows positive, so we'll say probably that we see that the test come back positive is equal to 0.95. Right? It's the first thing we're given. So I'm just writing this out because I think it's easier to have it written out as a probability. The second thing is, however, the probability the drug test shows positive given that an athlete is not using is 0.01. So now we really have this exact same thing. It's just now it's the probability that they are not using. Given that they're not using, the probability the test shows a positive result, or kind of these false positives, would be 1%. Okay. This is a little small. Is that better for you guys in the back there? Okay. Those are the first two things we're given. We're then told a recent, Deadspin article says that if I choose somebody at random, the probability they are just using steroids is what? 0.15. Okay. So those are the probabilities that I'm given, right? I might just write them out in order like that. Okay. Well, this one's pretty easy. If I might not need this information, but just to kind of be a complete example, show you a complete example, and also show you how in some problems we might need it. I'm going to do like the probability tree, but I'm going to show you a slightly different way to do it instead of drawing it out as a tree, right? If I just write these three things down that I was given here, what's the probability that they're not using? Well, if the probability they're using is 0.15, the only other possibility is that they're not using, right? So the probability would just be 0.85? Yeah, 1 minus that, right? These two things would have to add up to 1. I'm either using or I'm not using. Right? What about here? I could say, okay, given that someone is not using steroids, the probability they get a positive test result is 0.01. So if I do the same thing and say, okay, given that they're not using, what's the probability that the test actually comes back negative? Right? What would that probability be? Yeah, right. If I have someone in front of me and I know that they're not using steroids, and let's say I give them 100 tests, right? And I know that one of those tests comes back positive, how many would have to come back negative? 99, right? And that's what we're saying. We're conditioning on that same person. It's almost thinking about, yeah, if they took 100 tests, the probability that it comes back positive is 0.01, or one of those comes back positive. What about the other 99 have to be negative, right? And so if we're conditioning on the same thing, we know that those probabilities would have to add to 1 as well. Then we could do the same idea here. If I condition on that the person is using, what's the probability that the test comes back negative? Well, here I was told if they're using, the probability it's positive is 0.95. So if they're using, the probability that not the TET, but the test, the probability that the test comes back negative would just be 0.05, right? Now I know for the next 3 problems, I have all the information I could ever need, right? So I didn't necessarily have to get these. Potentially some of these problems might not need that information, but no matter what question I ask you now, you have the information you need to answer it. So we'll start with 13 just because I want to make sure that we get through it first, and then I'll kind of go back and do 10 and 11 if we have time. And we have 10 minutes, but I know this one takes a little bit of time to work through. So what I would do is, we have all this information up here. Write out what the question's asking you for. So given that the test comes back positive, what's the probability the athlete is not using steroids? So what is given to us is what goes on the right-hand side of that vertical line. So we're told that given that the test comes back positive, right, what's the probability that the athlete is not using steroids? Okay. So that's what we're looking for. Now, if I look at my formula sheet, where is it? No. Stop. Okay, so I'm going to go to my formula sheet here. If I want a conditional probability, I can rewrite that as the intersection divided by what I'm conditioning on. Now, the problem is, if I try to do that here, and I think about what my events are, I'd be dividing by the probability that just the test comes back positive. I don't have that. So usually, I mean, you can see from the practice exams, they kind of follow a similar order. But usually if you're asked for a conditional probability at this point, this equation is not going to work for you. But we know that we can break this equation down into Bayes' theorem, right? And so if I look at Bayes' theorem, I'm trying to find this conditional probability. Here's my S, right? So I could almost identify, here's my S, and here's my E, right? Here's my state of nature, here's my outcome for the test. I think the easiest way to do this, write this example out in the context of write this formula out in the context of your example, all right? So what I'm gonna do here is, okay, take the probability of S, my S is that they're not using, so not using, multiply that by the probability of E given S. Okay, my E is that the test comes back positive, given my S is that they're not using, right? And I'm just writing this out using my example. Now notice here, so that's my numerator. Right? And actually, I'm not gonna do that because it'll make it look goofy. So I'm gonna divide that by what's in the denominator here. Right? So what I'm gonna be dividing by, notice the very first part of this denominator is the exact same as the numerator. So I really could just write this exact same thing down again, maybe. Very good. And this is not looking pretty, so I'm going to hit enter here so it looks a little bit better. All right. So my numerator here is the very first part of my denominator. Okay. I'm then going to add to that, if I go back to my formula sheet, the probability of S complement times the probability of E given S complement. So in my example, my S complement, well, if S is that I'm not using, S complement would be that I am using. I'm going to hit enter here so this hopefully looks a little bit nicer. And this should be up here. So here's my S, here's my E, right? Here's my numerator. Maybe we can make this look a little prettier. Imagine this is a straight line for a second. I'm dividing by the denominator, right? So S complement is that they're using times the probability of E, so that's that the test comes back positive, given S complement. My S is that they're not using. We said S complement would be that they're using. So at this point, it's really just plugging numbers in. Once I have it written out in the context of my example, what's the probability someone's not using? 0.85. What's the probability that given someone's not using, the test comes back positive? Given that they're not using, given that they're not using, Probably the test comes back positive is 0.01. Plug that in. Remember, the first part of the denominator is the same as what's in the numerator. So I just plug those numbers in again, 0.95, 0.01. The probability they're using, 0.15. Actually, I think I might have said that backwards. The probability they're not using is 0.85, right? I think I went up here and got it right. Probably they're not using is 0.85. Sorry, I just want to clarify that. Then the probability that given that they're using, the test comes back positive. Given they're using, the probability the test comes back positive is 0.95. So this was an example where I didn't have to find any of these, right? I actually didn't have to do that, but I just wanted to be kind of complete in showing you how to do this. Also, you know, you can kind of imagine if I would have just switched one of these to, you know, given the test comes back negative, then I would have needed all these probabilities. Okay? But once I plug all my numbers in, then it's really just, you know, a little bit of multiplication and division, making sure I've got my order of operations correct. Any questions on that one? So I think if we plug in the numbers in here, it'd be what, 0.85 times 0.01 divided by 0.85 times 0.01, and then we added to that. The probability of using was what, 0.15 times the probability that the test comes back positive. Was that 80%? Or am I remembering? 95%. Different example. Okay. So that's how you would do a Bayes theorem problem. Right? You know, it's up to you whether if it helps you. You know, I've got a lot of words going on here. For, you know, if it would have helped instead of not using, you put NU, or, you know, using was just you. You can do it that way as well. For some people, I think writing out the actual words, it does take up more space, like wherever you're working, but maybe it kind of helps you keep things a little bit more clear. It's really up to you. Okay? But I would suggest, one thing that also helps is if I try to do this as like, the HIV example is a good one. Like if I write HIV positive and then I don't write that the test is positive, I just write positive in there. It's easy to like get mixed up. What's my state of nature? What's my outcome of the test? So usually for the test, the outcome of the test, I always like put the test is equal to this, right? Or jury equals guilty, or whatever the example is. Okay. I think we'll probably